All right, well, let's do it. Let's get started. Hi, everyone. Welcome to another Aquapore Investor webinar. I'm Greg, co-founder and CEO of Aquapore. I'm joined by Josh Chastik, our product engineer. And we want to, first of all, thank you all for taking time out of your evening to join us. We've done a couple of these recently, and we're gonna do this one very similar to the previous two, so similar format. In terms of length, we'll keep this well under an hour. We are going to go through a presentation, should take about 20 minutes, and then we'll open it up to live Q&A. So any questions that you have, we will answer live and try to give you feedback right here. The topic or the purpose of this webinar is really a year-end review for 2023. We're going to look back at some highlights and milestones that we accomplished that we're excited about. And then, of course, we'll look ahead to 2024 and talk about some of our plans and projected milestones for this year. I guess to start, I want to give a high-level overview of how I felt 2023 went, and then we'll get into the more granular with Josh on the product development front. But ultimately, I look back at the year, and it was a really important year for Aquapore. It was a really good year. I think for a lot of people on the outside looking in, it could seem like a lot of the progress we made might have been a little mundane or not that big a deal. But what I can say is when you're up close to this, everything that was accomplished on the product end was absolutely critical for where we're heading with the company. And so we're very pleased with the progress that we made on that front. I think that in terms of, where we're at as a company, and I look and I hate to compare us to other peers, I guess, if you will, startup peers that might not be working on the same technology, but they're in similar spaces. We can't help but kind of compare ourselves to, some of the progress we made. And when you look at where we're at, we still have a small team in comparison to some of those companies that raised Series A venture money. We're underfunded. But I think the great paradox of all of that, when I look back at the year, was those quote unquote constraints led to some potential breakthroughs for the company. And I want to, in a sense, extol the virtues of our crowdfund investors because we've been able to get more done with what would be considered less capital. But it's you folks that are allowing us to continue to get this really important work done. And so as I look at it, and by the way, some of these companies that raised huge Series A rounds at the end of 2021 or into 2022, there's a handful that are out of business today. And what happens is you have all this capital on hand and you are in a sense forced to grow at a certain trajectory and you don't yet have product market fit. And you run out of money, and they literally shut down because of that. Whereas we are approaching this the complete opposite way, where we're developing, product and the technology alongside developing the markets as we figure out what this technology really is and what it can do. And so we're very excited and grateful for the year that we had. Everything is still in front of us. We have a plan for the milestones in 2024, and we're in a strong position. So that's kind of a high-level overview. Now let's get into some granularity on the product front. And I'm going to kick it over to you, Josh, and you can talk about, because you are the closest to the technology and the development of our products. So anything that you want to hit on in terms of what we accomplished that way.
So at the beginning of 2023, we were well on track, but we still had a few, I wouldn't say critical errors, but we had some issues to address. And I think we mentioned in one of the last two podcasts about the customized forms that we're now getting. They're rubber polymer forms, and they make all the difference with our material. So that was huge, but we had a ongoing problem related to the release of free water under heat that was causing cracking on the surface of our pavers. Water is strong, like I've mentioned in the last few, surface tension, and it's all related to that. But we've overcome that with a few different heating and mix techniques, which can't really tell you all the details of. As well, or should I say, in congruence with that, the heating aspect, we used to have to heat a lot longer at higher temperatures, but now we're able to use very low temperatures for a shorter period of time to achieve our goal and without cracking. And beyond that, we could get into all of the different materials that we finally have sized properly.
Well, and I think that's important. I mean, I think we can keep that piece of it general. I don't want to bore everyone to death, but the sizing of the material is totally a critical component of the concrete coming together without cracking, being strong enough and durable enough to go into commercial production. And so, to your point, you know, and I want to tell everyone listening to this, for me, it was the speed bumps that we encountered. There were a handful of times where we thought we were there, like we were commercial ready, project ready, and there were just these small variables, very important details that we had to work through, that we did work through. And now, would you agree, we are as close as ever to having commercial viable, commercial ready mixed designs and products ready to go to market?
I would totally agree with that. And in solving all of these issues, the cool part was we had theorized how to solve these problems, but it takes a lot of time to actually go through all of the samples, make them, figure out your results, and see if your theory's correct. But we were pretty spot on with most of our theories, obviously not down to the exact amount, but we now have a finalized product that could go to market, has proper flow, proper strength, proper durability, and it looks good.
Yeah. And then also on that front, we have gotten closer and closer with supply partners. And so the supply chain of getting the materials to where they need to get in order to manufacture is set up. We have solid supply partners, our concrete material supplier. We have a great working relationship with. And also keep in mind, you know, when we're going out to source these materials, we're getting them from suppliers that supply very big, very heavy industry. And so to get their attention and get them, I guess, for lack of a better term, excited enough to really work with us to make sure that we're getting the right size materials, I would consider that a huge milestone for us. I mean, that was something where I look back and I think that was one of the more important things, aside from all the development on the product end, one of the most important things that happened to us or happened for us this last year. Here are a couple pictures of really nice finished product. If you want to talk any more about sort of the surface of the material and the look, I mean, aesthetically, we also developed a few things that I think make it more commercial ready than ever before.
Yeah, so the new forms that we have a specific grit texture to them, which we settled on because it helps break up that water tension on the surface and create a higher flow with less water. Obviously, if you stack water a foot tall, you're going to get a little pressure from that water to help the water enter the brick. On top of the fact that it helps the water go through, it also adds an aesthetic appeal. And anyone with a pool or hot tub who needs non-slip... No, I think we've come a long way. We've got a product. I mean, we used to have issues with fluffing due to byproducts being generated and impurities in some of our other materials. Back to the material, discussion. And these large scale material suppliers, they do large scale, and they also have hundreds of options. And so we literally got 80 different 5-gallon buckets, and we had to decide what actually worked for us. Size, purity and quality kind of go one and one, but quality of it, and then how impure, what impurities are in there. So I think we've come a long way going through all of those, getting us down to where we have a smooth, workable finish that also flows and filters.
Yeah, that was a big milestone as well. No question about it. And that was, as you folks could probably imagine, pretty tedious work to sift through all kinds of different material that was the same material but a different quality, different gradation. Just working through those variables it took a bulk of our time during the year, and we got there. So we're really excited about that. And that kind of parlays us or takes us into potentially the next phase of our business now. Well, I want to talk about project opportunities. And specifically, I want to talk about a project funnel that is growing. I should say project opportunity funnel that's growing. We have, and I've mentioned this before in previous webinars, over 50 project opportunities that have come in. Now, I'll caveat that by saying there's a very small handful that this year are even considered desirable to take on or feasible to take on. Amongst those, the main project we're looking at right now, we have a letter of intent on. It's a commercial project here in Spokane. I think it would be, again, and I've talked about the project in the past, a great highlight. I think the size and scope of the project will show kind of our capabilities. It'll show off the, concrete and the technology, obviously, but it also will stretch us a little bit in terms of having to design and then deliver that project. That's something that we could get into the design and feasibility phase probably later spring. And then if the project ends up being feasible and it's something that we know we can capably take on, it'd be something that we do later in the summer. Now, before that, though, we have 2 or 3 other small demonstration projects that we could do here, again, in the Spokane area, probably, as early as this spring. And so those are projects that we're going to look very closely at. We want to get in the ground. And the idea being, we get these projects in the ground, we can collect data, we can even build some case studies around those, and then you use that to then go out and see, not only market to municipalities and developers and even HOAs, but use that data to really go out and see what other projects in the funnel we can take on. The last point I'll make on that is it's interesting to me, and it's actually quite exciting. We haven't marketed our product or our technology specifically to like the construction industry. So we're not doing any targeted marketing, but these opportunities are still coming in. And it's mostly from just the marketing we've done through the crowdfund. And so what that tells me is there is plenty of demand for this technology. So that's exciting, and that will obviously parlay into bigger project opportunities as we move forward. Anything that you want to add about some of the demo projects, what we would look to accomplish with those, anything on that front?
So ideally, we would have 3, potentially up to 6 different demo projects in the ground, depending on, some of them might be in a backyard, but we're looking at different soil types, because right now we're working on the engineered in-ground design, and we already have a baseline, but this is going to function differently depending on the drain rate of the soil you put it on. So ideally, we're going to put this in a couple different locations, including the absolute worst on top of clay, which doesn't drain. And we want to learn as much as we can about, engineering tricks that would help us make Aquapore optimized in all situations. It's not going to be the same on top of clay, but if we could make it functional for whatever the problem was, we can still solve problems.
Absolutely. So that is kind of what we're looking at on the project front as we head into 2024. We're obviously well along. We're already through January. Now I want to give you all just a quick look at sort of the financial situation for the company, give a quick snapshot. Obviously, right now we have a crowdfund going. That offering continues to be live and it's open. I think we've raised $561,000 in the round through or from 389 new investors. And again, the crowdfund investors should be celebrated right now because this is capital that is allowing us to get really important work done. And as it steadily comes in, we steadily continue to advance the technology and get us closer to, these market opportunities. So it's extremely valuable to us. In terms of burn rate, it remains conservative. I think we burn anywhere between 35 to 45 grand at the very top end per month. And so, we're obviously very cognizant about keeping, cash on hand. We want to have ample cash on hand, which we do right now, to get to the next milestone, which really is getting these projects in the ground. So financially, everything's looking good on that front. Again, we've been conservative. We try to, watch every penny if we can, and make sure that we're getting the most bang for every dollar that comes in, that we reinvest in a development initiative or, advancing the technology. So we've been cognizant about that. Moving forward, we definitely will have future capital needs. I would say that these are more geared toward growth. And we're also looking at different ways to finance some of these initiatives moving forward. So, likely we'll do another equity raise down the road. But we're also looking at certain project financing opportunities for a couple projects that we have ahead of us. And we're also, and I'll talk about this on the next slide or two, we're looking at some federal non-dilutive grant opportunities, which actually look very promising the more I've dug into that. But, as we look toward these future capital needs, really what we're looking to do, and I'll hit on this in the next slide as well, we have the opportunity, and we're in very early discussions to acquire a new engineering right that has to do with the material engineering of this porous concrete for very different uses and very exciting uses outside of stormwater. I'll talk more about that. We also want to continue to develop partnerships with our concrete material supplier and manufacturers who will make Aquapore concrete, and then of course support projects that we take on. So we need to have obviously some cash on hand to have the resources, even as we get into revenue generating projects, to be able to go and take on the projects. And the bigger the project, the more capital we obviously want to have on hand. And then of course, we want to continue to bring on key hires, Josh being our first real key hire in 2023. As we have the resources and the capital, we want to continue to bring on technical support staff and even a C-suite, some executives that can work alongside me to really grow the company. And so that's what we're looking at on that front. And now to get to the year ahead. It's all out in front of us, and we're excited because we have an opportunity that with where we're at today that we haven't had before. So first and foremost, testing and data collection on the actual product, both internally and then moving into third-party testing. Anything you want to speak to on that front? Because I know you've already started some of the internal testing.
So we've already begun flow and filter testing. Can't announce the results yet. On our last 3 variations of our product, including the most recent, just doing some comparisons, because as a scientist, you have to make sure what you think is the best when you compare it to everything else you've done. But we're getting great results with flow, filtration, and I've been building a bunch of cool apparatus. I built one today. Wasn't set up enough to flow water, but something to demonstrate what this does visually. And so the apparatus that I built today is going to be made out of plexiglass. It'll have one of our pavers in there, and we'll be able to fill it with muddy, dirty water. And you'll be able to see not only the flow of the water through it, you'll be able to calculate a flow rate based on surface area and how much water is going through it. But you'll also be able to see that the water coming out of the bottom is quite a bit clearer, if not crystal clear. Is my opinion. It's going to be crystal clear.
Can't wait.
And I think that's going to connect a lot of dots, because I know a lot of people understand, they've got a good idea, a good feel, but when you see it for yourself, it speaks volumes.
Yeah. Yeah. And you see the volume, to play on volumes, the volume of water that it can take on, I think is potentially a game changer. And so as we get those results too, now we're able to start building out a technical specification that can be handed to civil engineers, landscape architects, construction professionals, to where now they can go out and start designing with the product. And so that's all on the docket for 2024. Of course, the demo and pilot projects that we just talked about also on the docket. A phase 2 pilot project. I call it sort of phase 2. We're in discussions right now with a company that may potentially finance. It's our concrete material supplier, supply partner that may finance a larger scale pilot. Again, we're in discussions to see how this would work out. Be a larger scale pilot. We're talking half a mile to a mile of an urban or suburban neighborhood that showcases the full breadth of the technology in terms of stormwater management and then our stormwater designs. We have a muscle car outside, so I apologize about that. And yeah, so that would be toward the latter end of the year, most likely. And that's a bigger project. That's, $500,000 range project. And so then you really start showing the scale and scope of what we can do. I am also currently working on, and I'm deep in it right now, some federal grant opportunities, specifically through the Department of Energy, National Science Foundation, and AFWorks, which is sort of the innovation arm of the Air Force. We have some opportunities there. Actually submitted a letter of intent to DOE just on Monday, and those applications come up ranging from February to March. So I'm working with a team of specialists and a grant writer and some folks that are really helping me navigate that world. But some of these opportunities are right down the alley of what we're trying to do, both on the concrete, low CO2 concrete side of things, using industrial byproducts or waste in our concrete, and then of course on the stormwater front. So we're excited about that. And then I want to save the thing that I'm most excited for the end here, and that is, again, these discussions we're in to garner new engineering rights, and they would be material engineering rights to this catalytic concrete for very different applications. We have referred to the underlying technology as a catalytic concrete, the binder system. And the reason that is so is because it does some very interesting things chemically with different feedstock under different situations. And so this particular, without saying too much, we're working with a private energy company. They've developed a way to take carbon-rich or hydrogen-rich feedstock and put it in this concrete binder system, our porous concrete binder system. You take that material up to a certain temperature, certain heat, and it produces gases, one of which is hydrogen. It also can produce fuels or bio-oils. It is a potential breakthrough when it comes to energy systems. And so Aquapore, what we will hopefully be negotiating very soon, are the material engineering rights for getting just the right mix and setting up the material to go through this process to produce energy. We'll also have a hand in developing some of the byproducts from this process. So after you go through the process, you have what we call a spent brick. So it's been through the process and you have this spent concrete material. It can be post-processed to create synthetic aggregates, which can go back into Aquapore's permeable concrete in a total full loop, full circle process. It can also go into other types of concrete. And you can also use that byproduct to go into the agricultural industry as, we'll say, an organic additive to improve crop yields. These are things where early testing results look extremely promising, but it needs to be further developed and further researched. But I say all this because I think we want to lay out the full breadth of the technology. It is an amazing technology. I will die on that hill. This is something that the world hasn't seen yet. And it also shows what the breadth of Aquapore is becoming. And so when we've talked about it for the last 3 years as becoming an EPCM, engineering, procurement, construction management company, that's what we are. And so, yes, we are focused on the stormwater market, and that's a great business unit for us. But there are other engineering applications that we're going to take on, and they may actually be quicker and potentially much bigger paths to sticky revenue that can then help support that stormwater business. Because as we know, cities, they tend to take a long time, and some of these other applications I think could take off even sooner than that. Anything on that front? I need some water.
Yeah, I guess I would say the one aspect of our binder system that makes it ideal, and I can't go into all the details, but when you're using high percentage carbon and hydrogen feedstock, whether it be liquid, micro fines, or larger chunks, previously surface area to volume ratio comes into play here. How do you get even heating across a large surface? And because of the permeability of our bricks and some of the underlying, aspects, metals, you get micro ovens. This whole thing becomes a bunch of micro ovens, and you're able to evenly cook liquids and micro powders, which before, they do it by blowing it into a cylinder of hot air, which is, less controllable, should I say. And so the breakthrough with combining our binder system and these feedstocks is pretty revolutionary. Not only are the byproducts that we're producing slightly different, and I can't say better yet, but different, they're easier to produce, and I think at a smaller cost because of some of the facets of how much energy it takes to heat this brick and how effectively and efficiently it heats the feedstocks we put in it.
Yeah, that's well put. And again, we need to get further along in the R&D, but we're well into it now. Our sister company's well into it, and it's looking very promising. There's no guarantee, but it's just another thing that I think could be a breakthrough. And it touches on not just one heavy industry, like 3 or 4 heavy industries could benefit from this process. So it's something we're super excited about. So we have a full plate in 2024. We've got a lot to do. We're going to obviously stay focused on one milestone at a time as we go along, but suffice to say, we're pretty thrilled. And again, I go back to, where we started 2023 and where we're at today. I think it's been quite the leap in progress. So with that being said, that's pretty much the presentation. We can open it up to Q&A.
No, that's great. We got a lot of questions coming in from people across all the different platforms that we're on today. So I don't really have a specific order that these are going in, just where I found them. But so let's start off with, here's a question from Instagram. The product seems developed, so what's holding us back from collaboration with small real estate businesses, or using the sidewalk curve development, potentially getting social and news media buzz, or even influencer, home builder collaborations, things like that?
Great question. It is. I would say the product is just now entering that phase where we're coming out of the prototype phase, and now the whole deal comes down to, or what's slowing us down, can we supply it? Okay, so can we get enough material and a manufacturer set up? So right now we're piloting at a small architectural precast plant here in town. Can we get that infrastructure set up and then be able to take on projects like that? And the answer is yes. I think as we get further into the year, we will be able to do that. But I think before then, we definitely need to get some of the actual testing criteria and some standardization done on the concrete. Unless a real estate developer that without a technical spec would just pilot it, then we can seriously talk. But I think the next step for us is that testing and standardization here in the first quarter.
Okay, that's great. I'll just kind of go through another question that I think is really associated with that question is, so one thing is somebody was asking on Zoom that would are your raw materials available across the whole U.S.? And then another question that I think is related is like what is like the runway? Like, do we know that there's enough of this raw material to last us for years to come? So where is the material coming from, and is it available across the United States?
I'm going to let you answer the second part of the question. First part, the main components of the material are one of the most abundant, I guess, compounds or materials on the Earth's crust. So they are everywhere. Now, in the size and gradation and purity that we need, we definitely have enough right now with our supplier in California to satisfy some large projects. And then moving forward, the beauty about the process of, and I'm going back to the process of the energy system, the byproducts that come off of that could keep feeding our material. I mean, I won't say into perpetuity, but it can actually be recycled back into our material to keep making more and more. So supply, I don't think at scale will ever, well, I won't say ever, but shouldn't be an issue.
Yeah, and the materials, they're mined in various locations across the United States, and you can rail car them wherever. But when we're talking about going to South America or Europe or some other part of the globe, they've got the same stuff there. They'll have to refine it the way that we're getting it right now to make it ideal, but there's almost an endless supply. I want to call it kind of, why aren't you selling this now? The give a mouse a cookie syndrome. Once you start, you got to feed the beast. And we've just been getting ready, and I think we are pretty much ready to give that mouse the first cookie now that we've got enough lined up where by the time we get through those projects, we will have more projects lined up, and the people who are helping supply these mass quantities, everything will make sense, which it already does mathematically. We need this many square feet, we've got this much product here, but implementing that is a process that you need to do at the right time. So we're waiting to strike till the iron's hot, and I think it's pretty dang close right now.
Yeah, it's a good point. Order matters
Yeah.
as we set up the infrastructure.
Okay, great. We'll have there's some technical questions coming, but I think before we get there, I think there's just some kind of I would say more fun questions, and a couple of good points here is one of them is do you have any projects for pool decks specifically? Since we kind of mentioned it earlier here, it's like I'm a huge fan of using the product for pool surfaces, safety alone. It'll stop injuries, and they also brought up a good point that. There may be less liability insurance at homes or hotels or something like that if this is implemented and it's proven out to be a safety mechanism for it.
Just to quickly beat Greg to the punch here, I already have 2 friends who are looking to get hot tubs who said they would love to use this as a hot tub pad. And I've got a few people with pools who aren't necessarily looking to redo their pool deck, but they do think it's fascinating to have a nice grip texture that won't have standing water on it for safety purposes. So those are all great points.
Yeah, I love that potential market. I think it's a perfect application. And then I think, residential pools, and I think, at hotels, exterior pools at hotels. And the liability issue actually is a real one, and there might be something there. So yes, that's something that's been on our radar, and appreciate you bringing it up, because it's something we're going to look very closely at.
All right. I think we'll jump into a couple of the usual technical questions that we get. Here's one is at the sub-micron level and in interlocking pavement installations, would traditional polymetric or ASTM graded sands affect the porosity when sweeping in the sand to fill the joints?
So this is a test that I haven't run on like a 10 by 10 installment yet. If you're talking about polylock where you add the water and it glues itself together, I think as long as you use it reasonably and you don't wet the sand across the surface, we should have no issues, but there'll probably be a prescribed way to apply the sand during installation that will guarantee the functionality of Aquapore as well as being able to put your poly sand in there, because that is important for keeping pavers together
Yeah.
and those nice lines.
Yep.
Okay, just a comment, and then more of kind of a very similar question is, there are tried and true designs with and without under drains, including expanded storage beneath a pervious or porous surface. This Walter, he says, I don't think you need to reinvent the wheel on that, and so all sorts of tests and all sorts of tests on different soil types. Have you tried testing on your system to specific ASTM codes? And he lists, ASTM C1 718 and 178 1M-13. So I don't think you guys know those off the top of your head, but I think general.
I don't have the numbers memorized, but I'm sure they're your basic. Probably has to do with strength. I would think tensile, compressive, slip resistance. There's a bunch, and we have the whole list of what we need to go into third-party testing with. We have not done that yet. We're starting with the basic internal tests to kind of know what we have, and then we do have an outfit that can do all of those ASTM tests as well as freeze thaw, and so we will do that sort of next. In terms of the design, you're exactly right. There's proven designs for permeable pavements. One thing, we won't reinvent the wheel, but one thing that we do have a design on is using very large detention cells. They're precast blocks basically, and they have porosity or voids that go up to like 40% porosity basically, and so it can hold a huge volume of water, and those can be designed based on a Houston design storm and the native soil, and so basic hydrology numbers that you would design for, and that's one design I think for the Houstons, the New Orleans, these areas that get very rapid rain events very quickly. And so you're right, though. I mean, we're not going to reinvent the wheel in terms of basic permeable design.
I guess I would say that, in a micro scale application, like we're talking a 10 by 10 backyard patio, do you want to have Aquapore or do you want to have pervious pavement with a French drain or some sort of drain system below it? We live in Spokane. We get about 15 inches of rain a year. You put us next to them, I mean, half dozen of one, six of the other, whatever you want to call it. When you get to larger scale is where you're going to see that Aquapore has advantages in certain circumstances. Not every circumstance, but we specialize in the filtration. So if it's your back patio and you don't have a bunch of junk, your stuff's not clogging anyway, and you're only getting 15 inches a year, so that thing's going to last 15 years anyway, because the pervious isn't going to have enough time to clog up your French drain system below, then, you could argue I would want one or the other. What's the cost difference? But when you get to larger scale applications or specifically high intensity applications where the filtration on the surface is actually adding to lifespan because the amount of particulates that are flowing into the system is so great, you're looking at a system where the whole substrate will be clogged in a matter of 5 years, and you could extend your lifespan to 10 years.
Yep.
Now you're looking dollars and cents time-wise, and it starts to make sense. So yes, not in every application is this going to be better than the wheel that's already out there.
Right.
Yeah, fair. So this will go to another question it's worded a lot nicer, but it's a simpler question, is how do geotechnical engineers feel about your product? Are there issues with the subgrade collapsing or loosening compaction? I think this is a sinkhole question, basically.
Yeah. No. And the reason I say that is because of the point the last person brought up was these designs have been around for a long time. And so as long as you are designing based on natural hydrology and some structural characteristics of where you're installing it, you should never have that problem. Now, there are situations like on a karst formation, for example, you'd never want a permeable surface because it is susceptible to collapse. And so you would always do pre-engineering to determine that, but in the end, the engineered design will determine whether it's feasible or not. And if it's not, we would never want to take on that liability.
And in comparison to, pervious concrete where you're getting 1,000 inches an hour of drainage, everyone is seeing Aquapor and they're visualizing a river under the ground. Now we've got exceptional flow for the filtration and strength of this, but when you see water going through our brick, it's dripping. It's not gushing
through. Yep.
And that gives the soil and the whole substrate a chance to spread that water out. And yes, water moves mountains, so there's gonna be a chance or a case where we have an incident of these things are flowing fast, and we'll learn from it. But I don't foresee that as our biggest problem.
Yeah.
Okay, great. Let's see here. This will be. Let me find the one that I. Let's ask some more. We'll kind of pivot just a touch here. When we buy shares from Aquapor, how much equity do these shares actually represent?
It depends how much you buy. And so right now the share price for Aquapor is $2.81. And so it just depends on, how much you're investing. One thing that I will say about that is it's all common stock. And what that means is you own the same class of shares that we do. So we're owners on the same level of stock in the company. And that's important because a lot of times and I'm not saying this is right or wrong, but sometimes a startup will go and raise venture capital and like a Series A, the venture capitalists, the investors, they want preferred shares. And so they have certain rights that the common shareholders don't have. And that can lead to messy things down the road. Whereas in our situation, it's all common stock. We're all in the same playing field. And if we're successful, you're successful type of thing.
Okay, here's a question that seems apropos is what's your cash level and cash burn?
Yep, I hit on that a couple slides ago. We burn about 35 to 45 grand a month, 45 at the very top end, and cash on hand is well over 230 grand right now. And then we have additional money that we could disperse upon in the crowd fund. So we're healthy in terms of cash on hand. On that note too, we're always very scrupulous about how we go out to raise money. And so we will never raise a round, and we never have in the past, without having a milestone that we're raising on. So we're very particular about, and I can't guarantee this in the future, but this is how we think about it, is always raising the value of the company each time we go out and raise that capital. So it's something that I keep a very close eye on.
Okay, that's great. Do you see licensing as a go-to market for U.S. and or international scaling? Yeah.
Yes, I mean that's part of the business for, I think I should say that's part of the business for permeable pavers. Okay, but bigger stormwater projects, we want to EPCM, we want to be the contractor and oversee those projects. For permeable pavers, that is something that we most certainly could license. And there's a good reason to do that, obviously. There's also a risk in doing that. And part of it has to do with quality control of the product and how it's made, and then contractors installing it. And so we're going to be very diligent about, not just installation spec, but a maintenance spec and all these different things that end users and the people both making and installing the product have to abide by. But yes, licensing, it makes a lot of sense for that particular business unit.
Okay, great. We'll just keep firing away here. Would varying the thickness of aquapore concrete solve some of the issues of varying types of substrate?
In theory, the flow rate remains the same per surface area. No, I would say no. Now, if you're thinking, I get a steamy bathroom and I'd like to suck it into the walls and throw it into something, maybe you're going to do a tile just for placement. We could go thinner because that makes a nice bathroom tile right there.
Yeah.
But as far as the quantity of water going through, I could double the thickness of this brick and we would still have the same volume of water moving through this brick at the same rate. The only difference would be if you double the volume of this brick, you're going to have twice the storage capacity. So there'll be twice as much water left in this brick that will slowly, after the water stops going in, will remain in there and slowly be released. So you'd have more in the storage vault, but the rate of flow would remain the same. And the filtration characteristics remain the same too.
Okay, great. I think this is kind of, let's see if you guys can parse this one out for me. Are there any concrete materials that will absorb CO2 currently in use?
Yes. I've actually been keeping up on this as well. Ferroc. There are a couple. There's some things under development that are pretty cool, different from what we're doing. If you want to, you can geek out on that if you want.
There are with Ferroc, it's absorbing CO2 in the process of its formation, but I don't think, correct me if I'm wrong, that it passively absorbs CO2 over time.
That's correct. I think you're right. And that's where my head went.
So you get like a one-time CO2 dump
Yeah.
or storage
Yeah.
versus ours, which is catalytic, and
Yeah.
it's actually actively interacting with the CO2 in the atmosphere and sequestering it. And can't get too into the details of that
Yeah.
yet, but this is actively engaged with the atmosphere, and under certain conditions, you can increase that activity, which is pretty cool.
That's exactly right. And there are other companies, by the way, that they are sequestering CO2 in a process that they call it mineralization, where they will take CO2 off the cement making process, re-inject it into concrete, and which is cool. I mean, that's fine. That's not what we're doing, and I'm not gonna denigrate what they're doing because I think it has a purpose. But yeah,
And some of the grants out there right now, similar to this aggregate grant, if there's a way I can take garbage, carbonaceous feedstock that will eventually become CO2, or if you use it in another process, it would be let off as CO2, and we can sequester that with our binder system and turn it into an aggregate. Yeah, you're sequestering CO2, but this is a passive CO2 sequestration, and throughout its life, it's constantly working.
yep.
Okay, great. Another question is what do we think the life cycle of the product is right now? Like, how long is the material going to last?
That's a great question.
It depends the conditions you place it under. I mean, if you're doing it as a pool deck in Spokane with 15 inches of rain a year and kids running on it, and maybe ride some little kid bikes on it, probably. I mean, it's all about the hardness. So right now, one of the questions, kind of going back to, why aren't you at the market yet? You have a product. What is the market we want to go to, and how do they want it specified? Because right now we've got a range of flow and a range of strength. And so we need to find the market that is suited for any application, and then we can cater this to it. And the lifespan will be dependent. If you make this more porous, more water goes through it, it's still going to have the same amount of filtration, but you're going to lose a little bit of durability, and durability is going to be lifespan. So
Yeah,
I can't put a number on
it's
it
hard.
right now.
It's hard to say because until we get it in the ground. But what we can say is it's a chemically bonded phosphate concrete that in theory should last over 50 years. Now, the fact that it's permeable, it's not going to last that long. I can tell you that, but I don't know. We need to prove it and get it in the ground. If it lasts 10 years, I think that's a good product because it's so easy to replace and reinstall.
And it's doing a lot of other jobs other than being a hard surface. It's filtering and infiltrating water at the same time as being something you can walk on, and it looks good.
Yep. Good question, though.
I think some of these we've kind of already talked about. We'll go to we'll go back here. So we've had let's just do we've got our random our every session question is how's the freeze thaw?
Freeze thaw is good. I actually just did this test. So we had a cold snap in Spokane where it was like -10, and then it'd get up to just above 0. So it was like -10 to 4 degrees for 7 days. So it was just a 7-day test, and it was a crude test because it was just me taking the product, submerging it in water, putting it outside, freezing it, bringing it back in, submerging it again in hot water, getting its flow back, doing that 7 times. And it looks great. No cracking, the flow rates remain intact. It's just as durable, when it was dry when I first put it out. So I am more and more confident in this material's ability to withstand freeze thaw. Now that was, 7 days, right? Can it handle 40 days in a Minnesota winter? I don't know. But we will get third-party freeze thaw testing done on it to get that validation. But just from what I saw in that really cold streak, it's plenty durable.
Okay, great. Here's another question. In California, we have used typical concrete pavers as a permeable surface where properties have limited non-permeable restrictions. Water able to flow between the pavers. How does your product as a slab poured surface compare? Have you done comparisons as yet?
So this is all going to be precast, and so it's going to be similar to those interlocking pavers. The difference is we don't rely on gaps in between them for permeability, and that's a good product. The problem with interlocking gapped pavers is those gaps get clogged up, and once they get clogged up, they're extremely difficult to maintain, and so you lose permeability. But then when you have to replace them, you're not just replacing the pavers, you're replacing the gap material and the whole subgrade for the most part, because once the gaps clog, you're getting particulates into the subgrade as well. And so the big difference with this, the way to look at it is actually like a filter material where you can maintain it much easier than interlocking concrete pavers, where a vacuum sweep or street cleaning mechanism to get the particulate matter off the surface, and it will go back to, those high flow rates. We will have numbers, and we're going to prove this out here in the coming weeks with Silcasil, the testing Josh is doing.
Okay, great. We're kind of getting towards the end of the questions here, so some of these are feeling a little redundant, but still, we might have answered them a little bit already, but I'll rephrase them here. So, how do you envision your future scale up to make this marketable, and when do you see that happening?
Another great question. Well, it starts with this year, getting these demo projects in the ground, building a data set and, some case studies on those, and then going out after much bigger project opportunities at the municipal level, making sure that we have supply chain ready to go for those projects. And at that point, for the stormwater system, now we're looking at, material and installations in the miles. And so those are pretty big projects. I mean, I think a mile, of our permeable sidewalk system is over a $2 million project. And being able to scale up from there. Well, when you think about scale now, 1 mile, it's a $2 million project. In LA County, for example, they have 9,000 miles of sidewalks that need repaired. and they have big water issues in LA County. And so now you start seeing, well, once this is proven out, how it could go pretty rapidly that way. And so that's how I look at scale. Are we going to get there, overnight? Absolutely not. But I think with some of the other engineering applications and things that we're working on, that might be quicker revenue and decent sized and sticky revenue that helps support that business as we get that off the ground. Because I think this could be an absolute game changer for cities. And you're not going to make every sidewalk system out of this, but even if, a quarter of the sidewalks in any given city was an Aquapore permeable system, I think you have a pretty robust business.
Cool. Yeah. And speaking of that, good question here is: do you see these tiles or pavers sold retail, like at Home Depot, for DIY projects?
We talk about that all the time. Yeah, I do. I think that's another thing down the road, though, and that's a whole different business unit as well. But yes, the answer to that is yes.
And if anyone's got creative ideas, you've got some issue in the area you live in, Aquapore would work, we'd love to chat with you, because we get people from all over the world who have very specific situations, and Aquapore could give them an advantage. I don't live all over the world. I live in Spokane, so I need all your input. We gotta open source this and get everyone's minds into how we can apply this to help water everywhere, because I can only think of one man's worth of thoughts.
That's a really good point.
Somebody just asked, you mentioned your sister company, and that sounded interesting. Is there anything more that they said, what's the sister company?
We will announce more when we can. There's some confidentiality there, but it's a private company, also based out of Spokane, that's working on some really cool stuff that pertain to energy systems and using, this catalytic concrete in different ways. We work very closely with them. They've been in quote unquote skunk works, kind of stealth mode, and they will be coming out of stealth probably pretty soon. And once that happens and we have, some agreements or, whatever the partnership looks like, we will definitely announce that.
Okay, great. Well, that pretty much wraps up the questions. And then we'll get to, it looks like one more just came in last second here. Can you design pavers that sequester pollutants like fertilizers from entering with a water supply?
So that one's usually pretty tricky if you're talking about fertilizers that are dissolved in water. But we are looking at using this as a filter system, like we had talked about. PCBs, anything that sticks to particulates can be filtered with this. And there's also a huge issue out there related to rubber and plastics on the roadways from tires, from airplanes and cars. And I'll let Greg go on this one because he's got a little more.
No, you nailed it. So tire wear particles, it's a huge pollutant. I actually was talking about this in a recent post, or maybe a campaign update, but tire wear particles, the particles that come off of vehicle tires, are responsible for 78% of all microplastics in the ocean, and that all gets there via stormwater runoff. Pollution. This is a huge problem, and it's a problem that we don't even know what the consequence is going to be of it yet. We know it's kind of harming marine life. We know that some of that marine life ends up on our plates if we eat seafood. This material is extremely carcinogenic, and scientists have noticed that certain green infrastructure techniques help minimize its impact by like 90%. So we are definitely going to test for that with our product. That is coming down the road, but I think that could be a huge new application for the material. So fertilizers, it dissolves, probably not so much, but some of these other really dangerous toxins we're definitely researching.
All right, great. We've hit the hour mark, so I think I'm going to pick just one or two questions to end it here. Somebody was asking, will Aquapore investors be grandfathered in the sister company, or is that a separate investment?
Good question.
Yeah, that's a good question. No, it's totally separate. We don't, that's not a subsidiary or anything like that. It's a totally different company.
Okay, great. And then this is a good question, I think, maybe to end the night, unless I see a bunch of really unique questions coming in. Is your end game to eventually go public with an IPO or to sell your technology and the company?
We've always said IPO because I want to see this through like long term, and and anything can happen, I guess, after that, after an IPO. But being able to continue to somewhat control where the technology goes, and we like the idea of public markets in a sense. Crowdfunding is sort of like the public market. We like that, and we want to make sure that this technology, if we can help it, never gets shelved. And sometimes when companies get acquired, the acquirer, will not. Some just shelve technologies, but others just don't see it to its full potential. So I would say IPO, but everything, we'll look at that when the time comes.
If we GameStop this, everyone can be a 0.5% owner.
Okay,
What
well,
do they
that's
say?
sort of
That was a joke.
yeah.
Yeah.
We'll leave that.
Last thing too, while I'm thinking of it, the sister company thing, that's a totally separate deal. But keep in mind, Aquapore with those certain rights. I mean, that's how, because I don't know what their plan's going to be in terms of going out and raising and how they're going to finance what they're up to. But what I do know is, as we work together and there's some right, assuming that we negotiate our way into that right, then that's where you catch the upside, of that. So
Either way, all you guys in the crowdfund now, you are early investors, so you're along for the ride. And
Yep.
we appreciate everything you guys do for us.
Yep. Cannot say that enough.
All right, great. Okay, well, thanks everybody for joining. I think that's going to end our live session for tonight, and we'll have this reposted again on YouTube and on the places, so you'll be able to review this again in a few days after we get it from the live to post it on the YouTube account.
That's right. Thank you all. Really appreciate your time. Those are great questions.
Thanks, guys.
Thank you.